for our next example of piecewise functions, we're going to get into a special situation here. And you can see that in example 3 we have multiple pieces to this piecewise function. So the first thing that I want you to identify is this, and we've mentioned this in class multiple times that this could be very important. We have f of x equals to 1. Kind of an odd statement there, but if you think about it like this is actually just saying y equals to 1. And if you recall, y equals to 1 is just a horizontal line at 1. And so then we have f of x equals to 2, we have f of x equals to 3, and we have f of x equals to 4. Now, basically what it's saying is that we're going to actually graph 4 horizontal lines at those particular values. So if I just did that with my highlighter function, you could see here that I would graph, very clearly a lot of lines going on there. But that's obviously not going to pass the vertical line test. So then we have to look at our conditional statements here. In the conditions in which we're doing this, it gives us a range of values, or what we would call an interval of values. And so you can see we only want to graph y equals to 1 when x is between 0 and 1. And notice that it says that it's going to be equal to 0, an x of 0, but not equal to a 1. So if we look at that on the graph, that's actually going to be a closed dot at 0, but this little open dot at 1. And it's going to be the horizontal line for everything in between there. And so that's going to be the only little part of that graph that we're going to have. So y equals to 1, but only between 1 and 0, and a closed dot at 0 and an open dot at 1. And so in essence, that's what we've got going on all the way across each of these pieces. You can see the second piece is from 1 to 2. It's closed on 1, open on 2. Y equals to 3 is from 2 to 3. And then y equals 4 is from 3 to 4. And then of course we don't need all of those entire horizontal lines. We only have these little small pieces of each of these horizontal lines. Now, the net effect of this is it kind of creates this staircase looking effect. And since it does, we call this a step function. So what's going to happen here is that whenever you have these little pieces that are little horizontal pieces that create stair steps, we're going to call this a step function. Now it's very important that you do the open dots and the closed dots in the correct place so that it were to pass any particular vertical line test. Okay, so go ahead and try. Well, actually I take that back. Forgot that we're going to introduce to you an infinite step function. If the graph above were to continue on with steps infinitely going up and infinitely going down, what we technically have here is what we call the greatest integer function. Now, I don't want you to spend too much time on the greatest integer function, except for to understand what exactly it's telling you. The greatest integer function is labeled by g of x in this special bracketing symbol that you see here. And it's basically saying that for all x values, we take the greatest integer less than or equal to that value. And so it creates this infinite staircase function, if you will. So just understand that when you see this bracketed value, that it's going to continue on infinitely in both directions. So that is the greatest integer function. And we'll talk about that in as much detail as we need to in class. Here I'm just going to leave it at that. So let's go ahead and go to our sample problem. Here you can see that we have another step function with different ranges for that. So go ahead and pause the video and try to work this sample problem. Go ahead and graph this step function for me. Okay, and so we can see here again, if we're graphing y equals to 1, y equals to 2, y equals to 3, y equals to 4. That's a bunch of horizontal lines just like that, clearly that's not going to pass the vertical line test. So we need to figure out what the conditions are and the range of each one of them. So you can see for y equals 1, I'm going from -4 to a -3, and it's equal to -4 but open at the -3. And then from our y equals to 2, it's from -3 to a -2. Now keep in mind that the range values, or the interval value here could be longer, so these steps could be longer. They don't have to just be 1 unit every time. So this one's going to be -2 to -1, and this one's going to be from -1 to 0, and then of course we don't need these right here, and so that is our step function for this particular piecewise graph. Okay, so that kind of wraps up piecewise functions. In the next lesson we will actually talk about the most common piecewise function that you know, and that's the absolute value function.